All right, folks, this is 8-8. It's factoring by grouping. Essentially, it's really very similar to the AC method. It's actually, I think, a little bit easier than the AC method because you don't have to do anything to get the problem set up. Like the AC method, we actually had to kind of rewrite the ax squared plus bx plus c. Here, it's already going to be done for us. Okay. So you only attempt factor by grouping if you have an even number of terms. Okay. So grouping, your groups basically when we do this have to have the same amount of things in them. So to do that, you have to have an even number of terms. For the most part, ours are going to be 4 terms, but eventually you can do it with 6 or 8 or 10. Step 1 is to rewrite, if necessary, the polynomial in descending order. Make sure all your exponents are going from largest to smallest. That's critical. On standardized tests, well, a lot of times if you had to use this, they will purposely write them backwards. Let's see if they've got one here. I don't have any written backwards, but that's what they would do. Step 2 is to factor out GCF. Okay, so if everything's divisible by like 2 or 4, or look at this one here, they're all divisible by Q. They all have Q in them. They all actually have a 2Q in them. So we'd pull all that out first. Then the next thing is you'll put parentheses around the first 2 terms and the second 2 terms. You'll factor out a GCF out of both sets. And this is where it becomes like the AC method. The stuff that's left in the parentheses should be a factor, and the things that are outside the parentheses are another factor. And we're going to write our factored form as this, okay? And this is just showing a lot of times there'll be 2 things being multiplied together, but occasionally it might be 3 or 4 or 5. We maybe see that here in a little bit. So I'll go through, we got a handful of examples here. Again, watch these as many times as you need to, but the overall procedure is very similar in all of them. Okay, so first step was to see if there's a GCF. Okay, factor out any GCF. And in this instance, let's see, are they all divisible by 3? They're not. Are they all divisible by n? They're not. So no GCF. So then you just work to the grouping part. So I'll group those 2, and I'll group these 2. We'll look at the first 2 and think about what they both have in common. 3 is divisible by 3. 12 is also divisible by 3. So there's the numerical GCF. And then they both have an n squared in them. Okay. Remember what we're doing when we factor out GCFs. We're dividing each of these then by that GCF. So 3 divided by 3 is 1. N cubed divided by n squared. Remember, n cubed looks like this. N squared looks like this. Those cancel and those cancel, leaves you just the n. Or you can think about subtracting the exponents. So leaves you just n on the inside. And now over here, I'll do the same thing. 12 divided by 3, negative 4. And then n squared divided by n squared, just cancel out. Back here, okay, they both are divisible by 2. So this sign right here is always going to be the same as what that one is. So plus, bring a 2 out, and then 2n divided by 2 is n, and then negative 8 divided by 2 is negative 4. So now, remember the goal was that what was left in the parentheses was the same, and they are. So that becomes 1 factor. And then the stuff that's on the outside of the parentheses, that turns into our second factor. And we're done. You could FOIL this out, and it's going to get back to what we started with. But again, this black factor and this red factor, they could flip-flop if you want to, but it doesn't matter. All right. This only works. This only works if these are in descending order. This does not work if these are not in descending order. We'll look at the next one. Okay. So first thing is to recognize if there's a GCF in all of them. Okay, so that's even, that's even, that's even, that's even. I know they're all divisible by at least 2, so I'll take my 2 out. And then I'll have a q in them. So I take my q out, so 2q. I'm going to go through and divide each one of these by 2q and see what I'm left with. Okay, so 4 divided by 2 is 2. Q to the 4th divided by q is q to the 3rd. 10 divided by 2 is 5, and it's going to be negative 5. Q to the 3rd divided by q is q squared. 16 divided by 2 is 8. Q squared divided by q is q to the 1st. And now 40 divided by 2 is 20. It's going to be negative, and the q's cancel out, so I'm left with that. Okay, so now this is a situation where we factored a GCF out, but now we're still left with 4 terms. So I'm going to look at that thing. Okay, now because I've already factored a GCF out, there's not going to be another GCF inside, but there is a factor by grouping. I'm going to group those 2, and I'll group those 2. Okay, so looking at the first 2 that I underlined in red, they both have a q squared in them. Okay, so now I factor q squared, so that means divide this first one by q squared, so it's going to let me use just 2q. And I divide the back one by q squared, and it leaves me just minus 5. You can distribute that real quick and make sure that you get back to what I have underlined here in red, and you should be fine. Okay, now I look at the back 2, and they don't have a q, they don't both have a q in them, but they both have a 4 in them. So I bring out a positive 4. 8q divided by 4 is 2q. Negative 20 divided by the 4 is negative 5. So now what's in the parentheses is the same, so there's a factor. 2q minus 5. This here is another factor. Q squared plus 4. Now, that's fine, but if you remember, that 2q was a third factor. And that can't go away. That has to be brought down here. So 2q times 2q minus 5 times q squared plus 4. That is our final simplified factored version of what we started with. If you're going to multiply this out, I suggest foiling those 2 first and then distribute your 2q to whatever that foiled polynomial looks like. Okay. This one here, a little bit like the first. There's no GCF. Okay, so not everything is divisible by 4. So what I'm going to do is group the first 2, group the back 2. I see that the first 2 are now divisible by both by 4 and n squared. There's the GCF of the first 2. Divide this by 4n squared. 4's cancel. N cubed over n squared just gives me n. Divide this by 4n squared. N squared is cancel. 12 divided by 4 is 3. Okay. Now, remember, if there's nothing numerical or variable that divides a grouping, then you can always divide by 1. That sign is always this sign. There's no common factor, so 1 is what I'm going to look at. So now I'll take negative n divided by negative 1, and that gives me positive n. I'll take negative 3 divided by this negative 1, and it gives me positive 3. And there we see that that and that are identical. So there's one factor. And then 4n squared minus 1 becomes my other factor. Okay. Now this next step is a little bit tricky, and you have to always be paying attention to this, is when you're done, we want to make sure everything is fully factored. That is not. That is a difference of perfect squares. Okay, if you remember, okay, we had in the last videos, if I had a squared minus b squared, that turns into a plus b and a minus b, where a is the square root of that first term and b is the square root of the second term. So here, if that's my first term, a is the square root of it. But what that means then is that a can be found taking that. So what's the square root of 4? It's 2. And what's the square root of n squared? It's just n. So there's my a value. My b value is 1. So what's the square root of 1? It's just 1. So a is a is 2n, and b is 1. So the way I'm going to write this 4n squared minus 1, I'm going to write it as a plus b. So our a was 2n, plus b, which was 1. And then a minus b, so a is 2n minus b, which was 1. If you were to FOIL this, 2n times 2n gives you 4n squared. That gives you 2n. That gives you negative 2n. Those cancel each other out. And then last times last will give me negative 1. So this does give me 4n squared minus 1. So that's how that factors. And then you still have this n plus 3 here tagging along. Those three numbers being multiplied together will give, or three expressions multiplied together, will get you back to what we started with. Okay? So this thing, what we're doing here, think about this. If I gave you like 12, a lot of people say, oh, well, 6 and 2 are factors. And I agree 100% with that. Okay? Much like those two things right there are factors of what we started with. But can't that 6 be brought down and factored further as 2 times 3? And that's all we're doing here. This here can be factored further down to that. And then multiplied by the other factor of n plus 3 that we already had. Just gotta keep that in the back of your mind as you're going through these examples. Next one. Okay, they all divide by 3. All those numbers are divisible by 3. And they all have an n in them. So there's a GCF that can factor out. So I'll factor that out. See what's left over. So 3 is going to cancel out. N to the fourth divided by n is n cubed. Those are going to cancel. Leave me minus 4. N cubed over n is n squared. If we do this right, you're going to see that these exponents are all 1 less than what they started as. So 4 goes down to 3. 3 goes down to 2. 2 goes down to 1. So 5n to the first. And then this is going to be, goes down to 0. So 60 divided by 3 is then 20. Alright, so that's good. Now we're going to take this thing. So 3n is a factor, and that's going to have to come all the way down in our answer eventually. But now we're going to factor this. So I'm going to group the first two. So I'm going to use the highlighter to do this. So group the first two, and then we'll group the back two. So out of the blue, they both have an n squared in them. Okay. So if I divide that by n squared, divide that by n squared, we're left with n minus 4. Look at the green. They both have a positive, because that sign right there, so positive 5 in them. Take 5n divided by 5 gives you n. Negative 20 divided by 5 gives you negative 4. So now we're going to take this stuff on the outside. That becomes a factor. So n squared plus 5. And then this is our second factor. Okay. Now if we look at this, we want to make sure, do we have any like difference of squares like the last example? And we don't. Okay. This does not factor any further. Okay. Something like a squared plus b squared does not factor any further. All right, so I'm going to run through these a little bit quicker than the previous ones, okay, but I do think we need more examples. So group and group, they were in descending order already. And actually, I didn't look to see if there's a GCF. If you don't recognize that there's a GCF right away, that's not terrible. You can do that at the end. Maybe the next one that has a GCF, I'll do that at the end. But this one, not because of the 15 here, not everything is divisible by 2. So group these. So now I know they both have an r squared and they're both divisible by 4. So divide them both by 4r squared. So 4r squared is out front, and then so that will cancel, give me a 5. r to the first. R squareds cancel there, and it's going to leave me, what, plus 2. If I look at these, they both have a 3 in them. Let's bring 3 out. And then 5r plus then 2. So, stuff on the outside is a factor. So 4r squared plus 3. Stuff on the inside, also a factor, 5r plus 2. Okay, so these all have a GCF. These all are divisible by 6, I believe. But let's ignore that. Let's say we don't do that right away. But look at that stuff. Okay, if I look at both these, I know they both are going to have an x squared in them. So divide them both by x squared. And they both have, if you see it, it's a 12. Okay, 24 divided by 12 is 2. And it'll leave you just x. Okay, 60 divided by 12 is 5. And x squared divided by x squared is just x. Or sorry, no x squared. They cancel out completely. Sorry. So 60 divided by 12 is 5. Now I'm going to look at this over here. And they are also both having a GCF in them. And if we look at the GCF, they're both divisible by 18. So I'll take a plus 18 out. 36 divided by 18 is 2. And 90 divided by 18, that gives me my 5. Okay? And the reason I kind of knew that I saw that 18 right away is I knew that my parentheses had to have a 2x in them. So I asked myself, okay, well, what can I divide 36 by so it turns into 2x? Obviously, it had to be 18. And I just checked, well, does 90 divided by 18? And it does. With 18 nickels, I have 90 cents. So that gives me 12x squared plus 18. That's that one and that one together. And I got 2x plus 5. Okay? Now here's where we recognize that there's a GCF still in there. They both divide by 6. So pull a 6 out. 12x squared divided by 6 is 2x squared. 18 divided by 6 is 3. So we get that. Okay? Now, you could do the same thing off the bat, but we recognize they all divide by 6. Take a 6 out of this entire, so 24 divided by 6 is 4. 60 divided by 6 is 10. 36 divided by 6 is 6. And 90 divided by 6 is 15. And now, I just think it becomes a little bit easier if we look at those two and those two. Think about the green ones. What do they both have in common? They obviously have an x squared. They have a 2x squared. Divide that by 2x squared, it leaves you with 2x. Divide that by 2x squared, it leaves you with 5. And if you look at the blue ones, they both have a 3 in them. So divide that by a 3 gives you 2x. Divide that by 3 gives you 5. Okay? So now the stuff in the parentheses, 2x plus 5 is a factor. The stuff on the outside is a factor. And then remember the 6 that we brought out, the GCF at the beginning, it is still a factor as well. That there is the same as that there. So the GCF can come out at the end, but if we do bring out in, what a lot of people forget to do is that they get down to this and they think, oh, I'm done. They don't pay attention to these numbers very often to recognize that there is another number out of them that can divide out. But if you remind yourself that you're always going to see if there's a GCF step 1 or 2 here, then you're never going to make that mistake. You're never going to overlook essentially a constant that is a common factor. Just keep working along here. Group these two, group those two. These both divide by a y squared, and a 2. So it gives me 14y. Sorry, not 14y. 14 divided by 2 is 7. Y cubed divided by y squared is y. Divide this by 2y squared, and it gives me just 4. So it's a special case right now. We see that this 7 and this 4 don't have anything in common. So they don't have anything in common, they're always divisible by 1. And when I divide by 1, it doesn't change anything. So now 7y plus 4 is a factor, and 2y squared plus 1 is a factor. We're done. This one here, fact, group the first two, group the last two. 11 and 9 are relatively prime, so they don't have anything in common. They do have a w squared in them. So then divide that by w squared to give me 11w. This will give me minus 9. This one here, again, only divisible by 1, so bring my 1 out. Give me 11w minus 9 again. So be w squared plus 1. 11w minus 9. I'll stop there for now. The video's getting a little long. Factor by grouping, again, it's one of the higher end formats of factoring. You're really not going to see a whole lot of this until maybe the end of Algebra 2, integrated, what would be integrated 3, in the beginning of college algebra, which would be maybe integrated 4. Okay, so touch base on it now, but in application and use, it really isn't going to be necessary for a little bit longer.